If you're working on AWS, you would have definitely touched upon different serverless offerings in creating your cloud native architectures. If you're not using AWS, never mind. I'm going to show you how you can leverage S3 and Amazon Lambda to create a serverless implementation in Java. I'll also be showing you how you can leverage AWS XRay to monitor your applications in production. Let's get started. We are going to take a look at the architecture diagram on what we are going to achieve, and later on we are going to see the console and the code on how we can achieve it. So initially I'm going to be the user and I'm going to leverage my free tier account which I created yesterday. I'll be creating a S3 bucket. This is going to be a fresh new bucket. There is nothing inside this particular bucket. I'm going to push a file using the AWS CLI. From my laptop, I'm going to use the AWS CLI, which leverages the AWS APIs to push the file onto the S3 bucket which I had created. From the S3 bucket, event notification is triggered to the AWS Lambda system, and from the Lambda, a Lambda function gets executed. So I'm going to create a Lambda function, a Java piece of code, which can read the file from the S3 bucket after the file has arrived, and I'm going to just print the content. In order to read the file from the S3 bucket, the Lambda needs to be assigned a bucket read access. So I'm going to show you that as well. So when I create a Lambda, I'll be creating an execution role for a Lambda, and in that role, I'm going to assign my read policy of the S3 bucket. I'll show that as well. As a bonus, I'm going to show you how you can leverage AWS XRay to track the flow and how you can use it for productionizing your applications, which are leveraging Lambdas and other resources. So the first part here in this architecture is creation of the S3 bucket. So let me go to the terminal. I already have the AWS CLI installed. If you're using Mac, you can do a brew install AWS CLI, or if you're using Windows, you can download the CLI, the same with Linux as well. So I have already installed the AWS CLI and the version is 2.0.6. This is the latest version which I did yesterday. Also, I have configured my account by logging in using the AWS configure. So I'm not going to do that. For now, I'm going to just list the S3 bucket which I have. Right now there are no buckets. So let me go to the console. This is my AWS console. Let me go to S3. So once I go into S3, you can see what is available in this particular account. I'm right now in the Mumbai region. S3 is global, so that's why it's not showing anything. Right now, if you look at it, there is no bucket. If I go to the Lambda, there are no Lambda functions available, and also I'll show you the EC2 dashboard because I have not created any EC2 yet. I'll show you that as well. So right now I'm in the Mumbai region, AP South 1. So right now if you see, there are no instances which are running. Now coming to the terminal, let me create a new bucket. So I'm going to do AWS S3 MB and I'm going to create a bucket. So let's call the bucket name as lambda-triggers trigger-files. So basically this bucket is going to have the files which I'm going to push, and from that particular bucket, event notification needs to be configured so that I can trigger my Lambda. So as a first step, I'm just creating a bucket. So the make bucket is successful. Let me do a ls, and this shows the bucket that it got created. Now if I refresh this console, I should be able to see that as well. Now the next part in the architecture is the Lambda function. Before we get the event notification sorted, we need to create a Lambda. In order to do that, I'm just going to create a new project called Lambda S3 to S3 trigger example. So this is the project. You can get the same project from the GitHub repo. So I'll be uploading the code into the GitHub repository as usual. But meanwhile, let me create this particular project and let me open it in IntelliJ. Right now it's a dummy project. I don't have anything here. It's just a folder. So what I will be doing is I'll be creating two files, the Java file and the Maven project. So I have the Lambda POM. I have already generated it and I'm just pasting it here. I'm not doing any change because this is just a template, because anytime you create a new Lambda, you can just use that. So I'm just going to rename some of the stuffs, com tech primers. I want to call this artifact as S3 Java, which is fair enough. So fine. I mean, I'm going to use Java 8 for my runtime, but I have Java 11 inside the AWS console, but you can use Java 8 or Java 11, whichever you want. So I've just put Java 8 here. The three dependencies which we would require are the Lambda Java core, the Java events, and the SDK S3, because we are going to read the files from the S3. We're going to read the events. So we have the Java events, and also we have the Java core, which is useful for creating your core Lambda code. Now I'm going to create some directories here. So my modules are sorted. Now I need to create a class. So I'm going to call this as the S3 trigger handler, because this is going to be the S3 trigger. So I'm going to call this as S3 trigger handler. Again, I have some code automatically generated, so I'm just going to use that. I'll just rename this particular class as S3 trigger handler. I need to refresh my IntelliJ project so that it can download Maven dependencies. Let me do that. So the Maven import is successful. Let me go to the Java code. So if I come to the Java code, I'll just walk you through the code. I already have pasted the code, but I'll just walk you through what's happening. So I'll be implementing a interface called a request handler. This is coming from the Lambda core library. So I'll be implementing the request handler, and my input is going to be an S3 event, because this particular Lambda is going to get triggered based on an S3 event. So this S3 event has its own POJO and stuff like that. So the moment this particular Lambda is triggered, there will be a set of JSON which will be pushed into this particular S3 event object, and we can retrieve our data from it. So here what we are doing here is S3 event.getRecords.get0. So I'm getting the first record, and from that particular record I'm getting my bucket name. So I'm storing the bucket name inside bucket name, and also I'm getting the file name from the get object method. So both these are retrieved. Now I need to create my S3 client. So I'm just creating my S3 client. With the S3 client, I need to read that particular object. So this is what I'm doing here. If you compare this diagram, so I get a notification to the Lambda, and I need to read this particular file from the S3 bucket. So via the notification, I get information about the file and also the bucket name. Using the same information, I am leveraging that inside the Lambda to read this particular file again. And that's what is happening here. So I'm just using a stream reader and then just reading it and printing everything as line. So whatever contents we have inside that particular file, we're just printing it as line. And finally, I'm also printing finished processing file. That's it. So this particular code is available inside the Amazon website itself. I got it from the Amazon GitHub repository. You can also use my repository, or you can already use the Amazon repository. So I'll give the link for all those in the description below. So if you go to this particular example, you can get this. So I'll leave these links in the description below so that you can take it. Now how do I build this particular project? I can go to the Maven clean package. I have added the necessary configurations inside the POM. You can take a look at it if you're interested. So the build is successful. Let me go into the target folder. Inside the target folder, we have two files. One is called the original S3 Java. The other one is called the S3 Java. So S3 Java was the name of the artifact. That's what we gave. Original is basically the lightweight version, but S3 Java is what we require because it has its dependencies and stuff like that. So let me go to the AWS console. We saw that the bucket was created. Now we need to create a function. So in order to create a Lambda function, you can go to the Lambda service, go to the function and hit the create function option, and you can create the Lambda function from scratch. So I'm going to name this particular Lambda as the same name what we gave, Lambda S3 trigger example, Lambda S3 trigger example. The runtime which we are going to use is Java 11. I'll just give the same. We need to create a role for this particular Lambda, and that's what this is. If you already have an existing Lambda role, you can leverage it, or if you want to create a new one, you can just say create a new role with basic Lambda permission. So this will create only the Lambda role. It won't have any access to the S3 bucket. So we will note that we will have to do that in the next step. So let me create the function. So while creating the function, you can also upload the jar file which we created, and also we can configure in fact this notification from the Lambda itself. There are two ways of creating event notification or configuring event notifications. One is by going to the S3 bucket and then configuring the Lambda. The other one is from the Lambda you can configure it. as a trigger, like how we can do here. So if you look at this, you can add trigger, select what kind of trigger you want. For example, S3 bucket is your trigger. You can select what bucket you want. You can select what object you want to create. So for example, here I'm just saying all object create. So whoever creates files inside this bucket, please get a trigger notification. Also, you can have a prefix or a suffix. I'm going to just have a suffix which says .txt, so I can add this notification trigger. So this is added the trigger. So whatever I have to do here, this event notification is done with this UI itself automatically, or I will show you the other way in a bit. So meanwhile, we have to come to the Lambda and we need to upload our code, right? So we had the Java code. Let's upload the jar file. So let me go to the source code and then upload it. Also, there is a provision here which mentions where is the class and the method. So here our class is present in com tech primers and then S3 trigger handler, and also the method name is handle request. So we need to update that correctly here. If you don't update it correctly, then it will not get triggered. So I'll just say com tech primers dot S3 trigger handler, and also the method name is handle request, which is fine. That's it. So do I need anything else? I don't need anything else right now. There is something called AWS XRay. So I also said that as a bonus, you will be seeing what is AWS XRay. I'm going to enable the AWS XRay. By default, it will create an execution role for XRay. That's what is the notification. I'll just click on the save option. As a part of the save option, my jar file is getting uploaded, and this particular S3 event is getting registered with my Lambda. Now, if I go to my S3 bucket, I should be able to see how I can configure it from the S3 space. So like I said, there is an alternate way for you to configure it from the S3 bucket. Now, if I come to the bucket, there is this option called properties. Inside properties, there is something called events. So this events is where we will have to configure. Notice that there is already one active notification, and this notification is nothing but the one we just created here. So if you had not created there, you can come here, click on the add notification. You can just provide a name for it. Let's say test notification. You can select what type of event you want to listen to. For example, whether you want to listen to all create objects or just put or copy. I'll just say all create objects or all create events. And you can have a different suffix. So for example, I can do a .jpg or I can do a .csv. I can provide a CSV file as well. And where do I send it to? You can either send it to a SNS topic or an SQS queue, or you can trigger a Lambda function. And that's what we are doing here. The moment I click on the Lambda function, all the Lambdas which we have in this particular account will be listed here. So we have this particular Lambda. So I'm just selecting that. The moment I click save, my trigger is updated. Now if I go back to our Lambda function and if I refresh it, I should be able to see one more S3 trigger because we have configured it from that. So if you look at it, there is this option called 2, right? I mean, the moment I click on it, I can see that there are two notifications. One is what we created with the .csv from the S3 console, and the other is what we created from the Lambda console. So this is other way of adding events onto the Lambda. Now this is all good. The final step which is missing is the bucket read access. Now coming to the IAM. So if you don't know what is IAM is a place where we have to manage our roles and responsibilities for securing our resources inside Amazon. So if I go to roles, every Lambda function will be having a role. Now if I click on this particular Lambda, this has a particular ARN and this will be assigned to a role. So if I look at the role, yeah, this is the role which got created for us, right? So this is the new Lambda which we created, Lambda S3 trigger example, and this is the role. Now if I go to this particular role, there will be something called policies. So policies are basically metadata about on what are the different accesses this particular role has. So if you look at this, currently we have only one particular policy, which is the Lambda execution role. So this particular Lambda has only an execution role. It doesn't have access to read the S3 bucket. So I am going to attach a new policy. So what policy should I attach? In this particular case, I want to read only the S3 bucket. So I'm going to add the S3 read access. So there are different roles. I'm just going to select the read only access because I just want to read the files. If let's say you want to create a custom policy, you can definitely do that. You can go to policy, you can create a custom policy only for that particular bucket and assign it to a Lambda. That way it is more secure. I'm not showing that, I'm just leveraging the existing policy. The only caveat here is my Lambda now will be able to read from all the buckets which are present inside this particular account, right? Which is not advisable when you go for a production kind of a setup. So you'll have to create a new policy and create that bucket specific policy onto this particular Lambda. So we're done with the bucket creation, we are done with the access to the Lambda, we are done with the Lambda creation. We have also configured it to use AWS XRay. Now it's time to test the application, right? Let me go back. Before triggering it, if you're still skeptical whether this will work or not, you can create a test event. So you can do a configured test event, just give the event name as hello world, and then you can pass the test message here. Here I'm just not going to do anything, I'm just going to create a dummy message. This is going to fail anyway, but I can just show you how you can test it. So the moment I click on test, it just shows that there is an index array about of bound index. So basically my code is getting triggered. So I now know that okay fine, my Lambda got triggered at line number 20, I'm getting an index out of bound, but I know that this is because I did not even provide my bucket names and stuff like that. So it's failing here because get object would have got some error. So which basically means my code is getting triggered. I'm just happy about it. So the test worked fine. So you can do the same as well. Now the test got triggered, so the Lambda function works. Now the only part pending is checking it from the S3 to the Lambda. Now let's push the file which we created here. So we created a temp file, right? So how to push or copy the file from the local directory onto the AWS S3 bucket? You can do this. You can do S3 AWS S3 copy, and you can copy the temp file. So you can just say temp.txt and you can just provide your bucket name using s3 colon double slash and then the destination file name, or you can just leave like this. So it will directly create your temp.txt. So I'm just going to do that. This is going to upload my temp.txt directly onto this particular bucket. Now let me go to the bucket and then see if the file got arrived or not. Let's refresh it. So the file came in, it's 21 bytes. Now let's come to the logs, right? So we need to go to the logs. So in order to do that, we can go to CloudWatch. So by default CloudWatch was enabled, so I can go to CloudWatch and check the logs, or I can even go to XRay because we had configured XRay here, so it's present here. So let me click on it. Parallelly we can go to the CloudWatch and then check if the logs are present or not. Let me go to log groups. Log group should have something. Yep, I can see my Lambda S3 trigger example which we created, and I can see some logs here. So if you notice, there was a initial index 0 out of bound exception, right, which we did via the test. The log was created that time as well. Also I can see the hello YouTube and be safe message from my S3 bucket, and also finally I pasted the finished processing line from the code. The Lambda is working fine. Parallelly, we had also opened the AWS XRay. So let me go to XRay here. So what is XRay, right? So if you're not familiar about what is XRay, XRay is used for distributed tracing. You can analyze the traceability for your Lambda, because most of the time when you start using serverless functions, you will be using multiple resources inside Amazon, and it might be tedious for you to trace where the request started and where the request ended and where is it pending or what failed or how many failed and things like that. So you can check all those using XRay. So now let's refresh XRay. I think we don't have enough metrics for XRay to check. So what I'm going to do is I'm going to push multiple files into the Lambda. So I'm going to copy the same temp file but with a different name. So I'm just going to bombard my AWS bucket with multiple files so that I can create multiple Lambdas. So the file got uploaded. Now I'm going to bombard it with the second file 2.txt. We're going to do the same for multiple times, right? So that way we can see some stats on the cold start and stuff like that. So I'm just going to bombard it with multiple files. Don't worry about the file names. Done. So we have just bombarded it with 4-5 files. Now if I refresh XRay, still my data is not there. Let me go into CloudWatch, because we had triggered multiple times, we need to get multiple logs. So if I go into the logs, I can see that multiple times the file has been read, and I can see the logs here. So the Lambda got triggered multiple times and it worked. So basically the bucket has pushed event notification to Lambda, and Lambda has read it and then just printed it. Now the pending part is the XRay. Now let's come into XRay and then let's refresh it. For some weird reason, my XRay did not get activated, so I think that's why the XRay is not showing up the data. Let me save it, and then what I'll do is I'll just push the file again so that we can now trace the lambdas. Let me go now and then just push some more files. 6. Enough, I think. Now let me come back to XRay. Let me refresh it. I'll go to traces. Yep, I can see now. If you look at it, the first one says it took 15 seconds for the Lambda to run, and then there was one which said 8 seconds only. There were 11 and then 19. If you notice, every request took different milliseconds for responding. For example, the first one is showing 7 milliseconds. However, the others are showing like 23 milliseconds. This is the cold start which we are talking about. So first time when a Lambda gets triggered, if I click on it, you will realize that first time when a Lambda gets created, it will need some VMs to be provisioned, right? So if you look at this particular request, which is the last request, it took only 7 milliseconds for the request to be processed, and then it just took whatever time for our function to execute. If you look at it, client is basically the trigger which we received from the S3 notification. We got the trigger to the Lambda, and then the function got executed. This took only 7 milliseconds because there could be already an EC2 instance or machine which already had our code. However, if you go back to this one, this might have taken more time than the 7 millisecond because it had to create that VM and then start it, and that's why we had that 23 millisecond. And what XRay provides is this kind of a traceability, and you can see how much time individual requests took, and there is a breakdown on what took longer. For example, the initialization took 300 and whatever milliseconds, and then there was a overhead, there was invocation, and then the processing itself took 10 seconds. So this particular Lambda was running for 10 seconds. This could be because the invocation or the code which we wrote is taking that much time to process. However, this first part is where it has taken 23 seconds because the VMs needs to be provisioned and stuff like that. If I go to another request, the same stuff gets shown up here. So you can leverage XRay to debug the traceability of your flow. If you're using multiple lambdas, you can definitely use XRay, and it will be very helpful when you're having production issues and you want to identify which request is slow and where is the delay. I'll just summarize what we did. So we created a S3 bucket and pushed files onto it. We created an event notification with the new Lambda code which we uploaded. We also provided the Lambda role, the policy of the S3 bucket, so that it can read the files from the S3 bucket. And once the file got pushed, we were able to see that the Lambda read the file and then it was logging the messages. Also, we finally enabled the XRay to see how the distributed tracing works within this particular flow. Obviously, I showed most of this manually by going into the console and then provisioning these resources. You can leverage CloudFormation, or you can leverage SAM CLI for provisioning the Lambda, or you can use the Terraform or other infrastructure as a code provisioning tools. I hope this particular video would have given you an idea of how you can provision events from an S3 bucket to trigger a Lambda. The functionality is going to be similar when you're leveraging SNS or SQS topics from the S3 bucket. I hope you learned something new out of this particular video. As always, if you like the video, go ahead and like it. If you haven't subscribed to the channel, go ahead and subscribe to it. Meet you again in the next video. Thank you very much.